Welcome back to Maths with Mrs. J. I'm sorry it's been a while since I've done my last video. I've been very busy tutoring students towards the end of the school year here in Australia, doing their exams and so forth. Well done to all my students for your wonderful improvement, wonderful hard work. I wanted to take the time to do a little bit more work with you on quadratics, both quadratic expressions and how we factorise those, and quadratic equations, how we solve those. There is quite a bit of overlap, and I have spoken about this before when I've talked about the discriminant. The discriminant is that expression under the square root sign in your quadratic formula. That expression there, b squared minus 4ac, tells us a lot of information about either the roots or solutions of a quadratic equation, or it can tell us about how we would go about factorising, or what sort of factors we would get with a quadratic expression. Let's just make clear, first of all, the difference between a quadratic expression and a quadratic equation. A quadratic equation has an equals in it, okay? So that's the main difference. A quadratic expression, you can't have a equal to 0. If a is 0, then you don't have a quadratic anymore. At most, you have a linear expression. You must have an x squared term for it to count as a quadratic expression. You may also have an x term and a constant term, one or the other or both. That's perfectly fine. It doesn't have to be x, of course. Your variable can be anything. It can be x, it can be y, it can be d, whatever the case may be. Okay, so that's a quadratic expression, and quite often we want to factorise those. Quite often the reason why we want to factorise, however, is in order to help us solve. So there is quite a bit of overlap here. Bear in mind we have learnt various techniques on solving quadratic equations, and I said to you in previous videos that the main way to solve, if you can do so, is to factorise your quadratic expression and then use your null factor law and go from there. If for whatever reason you're having trouble with either the factorisation step, or perhaps it simply cannot be factorised, which is quite possible, then you go ahead and use your quadratic formula. Now, one thing I haven't spoken about is the sum of the roots and the product of the roots. Let's just have a bit of a look at this formula for a minute, because we are going to use this to assist us in a minute. So if these are our two x solutions, so we call x1 would be our smaller one, so negative b minus square root b squared minus 4ac on 2a, and our second solution would be negative b plus square root b squared minus 4ac on 2a. Let's just think about what those two roots would add to give. So if we have x1 plus x2, we've got our negative b minus square root b squared minus 4ac on 2a, plus our negative b plus square root b squared minus 4ac, all on 2a. Now, it's pretty obvious they're on the same denominator, so we're all good there. Pretty obvious that we're going to get a cancelling happening. We're adding this after we've subtracted it. So we're going to end up with negative 2b on 2a, which is negative b on a. Bear that in mind. That's useful. It's particularly useful when a happens to be 1. Now let's have a look at our product. Well, our product is x1 times x2. What have we got here? Well, what we're in essence doing is we've got a difference of two squares. So we've got our first term is negative b and our second term is this square root here, all over your 2a, of course. So negative b plus this. So what's going to happen when we expand that out? We shouldn't have to do that the long way. We're going to get negative b squared, which is b squared, minus this square root squared. If you square a square root, you just get back where you started. So we get that all over. We need to square the denominator as well. When we tidy up the numerator, we notice the b squareds go. This is a minus negative, so we're going to get 4ac on 4a squared. The 4 and a will cancel and we're left with c over a. Again, bear that one in mind. That is particularly useful when a happens to be 1. So we've just established that if we have a quadratic equation in the general format ax squared plus bx plus c equals 0, then the solutions that we get, either via factorising and using the null factor law or using our quadratic formula, those solutions, the sum of those roots or solutions is negative b on a, and the product is c on a. This is particularly useful when we happen to have what I referred to as an EQ. Now, for those of you who are not my students, you'll probably find this a little bit weird. Even if you are one of my students, you'll probably find me a little bit weird. I basically divided quadratic expressions and equations into 2 types. So I've invented the terminology that if we have what's termed a monic quadratic, so in other words, a is 1, the coefficient of your x squared term is 1, I've deemed those to be easier quadratics or EQs. If we have a non-monic quadratic, in other words, a is not 1, I term those HQs or harder quadratics. And the methods that I teach for factorising those are slightly different. They're not at conflict with one another. However, it is obviously quicker and easier to do an EQ because you can, in theory, go straight to your brackets. Just bear in mind this information above, sum of roots and product of roots. If we do have what I call an EQ, if you have an EQ, then a is 1. So the sum of your roots is just negative b, and the product of your roots is just going to be c, because a, of course, is 1. So when we have our equation, x squared plus bx plus c equals 0, what we've actually got is x squared minus the sum times x plus the product equals 0. Why? Well, let's just think about the 2 possible solutions as calling them x1 or x2. Remember, using our null factor law in reverse, if we had x minus x1 times x minus x2 equal to 0, when we use our FOIL technique, first outer inner last, first outer inner last, we get x squared minus our x term, we get x1 plus x2 negative that x, and then negative x1 times negative x2 is positive x1, x2, which is just exactly our product. So this is why we're taking away the sum times x and adding the product. Bear that in mind. We're going to use that in a future video where I'm going to teach you an unusual but foolproof method for dealing with harder quadratics, all right? With a simpler quadratic like this, you're probably not going to need to use this new rule or new technique, but it will come in handy. So we have these made up terms that I've come up with for different types of quadratics. EQ are your monic quadratic expressions or an equation, if you have that equal to 0, where a is 1. Your x squared term has a unitary coefficient, all right? Or a non-monic quadratic expression like that, or equation if that equals 0, where a is not 1. Now, in the case where we have an equation and it's an EQ, then what actually happens is the expression, the sum of the roots is going to be negative b and the product is going to be c. In order to solve an easy quadratic, you do have options. Generally speaking, my suggestion is that if you can factorise and use your null factor law, go ahead and do it that way. So for example, say we had a fairly simple one, x squared plus 7x plus 12 equals 0. Here to factorise, we're looking for two numbers that multiply to give 12 and add to give 7. Bear in mind, I'm not looking for my roots here or the solutions, I'm looking for the numbers to put in the brackets. So 3 and 4 will do the trick here. So that's our factorised version of our EQ. Now you will notice that obviously when we use our null factor law, if this product equals 0, then either x plus 3 must have been 0 or x plus 4 must have been 0. So x is either -3 or -4. Now notice here the change of sign, S-I-G-N sign, not S-I-N-E sign. So bear that in mind. We get for our sum, we actually get -b. Notice if we add up -3 plus -4, we get -7, which is -b. Our product of our roots, well, negative times a negative gives you exactly the same, as you'll see. If you were having trouble factorising that, obviously you can go ahead and use your quadratic formula to solve. What if you had a quadratic expression, however, that you wanted to factorise, but you didn't necessarily want to solve the equation? Say you had something like x squared minus x minus 110, and you've been asked to factorise that. Well, what you could do is you could imagine that you're solving that. And so x is going to be -b, which is 1, plus or minus square root b squared, so 1, minus 4 times a times c, all over 2a. So we get 1 plus or minus square root 441 on 2. Square root of 441 is, of course, just 21. So we get 1 plus 21 on 2, or 1 minus 21 on 2. This, of course, gives you 11, and this gives you -10. How do you go from that to the factorised version? Well, we've said that x is 11 or x is -10. If x is 11, then x minus 11 is 0. If x equals -10, then x plus 10 is 0. So that can give us our factorised version there. Now, technically, you shouldn't have to do it for one of that sort of level of difficulty. However, you do have that option available to you, so just bear that in mind. Do just double check that you haven't missed a constant term anywhere. By constant term, in this case, I mean a multiple. So make sure you have actually got the correct thing. Sometimes you could have 3 times that, for example, or twice that or whatever.